Hi, hello friends, welcome back to my channel. In this video, we are going to continue the chapter Acid, Bases and Salts, which is given in the syllabus of TET exam, GPSTR and HSTR exams. So already I have made a video for explaining this acids and the chemical properties. It's in the playlist. You can kindly go to the playlist and check it out. And this video is the continuation of that, and we shall learn more about bases. Before moving to the video, if you are new to my channel, kindly do subscribe and press the bell icon so that you will get the videos which will be useful for GPSTR, TET exams, central TET exams, and also for HSTR exams. In the following days, I shall continue to take the classes in Kannada also, which will be useful for all the aspirants those who are preparing for these exams. As we continue with this bases. So, what are bases? A compound which reacts with an acid to give only salt and water are known as bases. So, this compound which is reacting with acid to give salt and water is known as base. So, here I have listed out few important properties of bases. Let us learn one by one. Any chemical compound that is bitter to taste. Okay. In case of acid, which will be sour to taste. Okay. In case of base, it is bitter to taste. BB. You just remember this. And bases that can neutralize the acid by reacting with hydrogen ions. And bases can turn red litmus paper to blue. Okay. What is the final color? Blue for bases. For base, blue color. It gives red, it turns red litmus paper into blue. And it reacts with acids to form salt and water. Okay, this which already I said. And they are soapy to touch. Like how we touch and feel the soap, right? Soapy touch. That is a kind of soft, which is not rigid, very soft, soapy touch. And they are corrosive. They have excessive OH minus ions in aqueous state. OH minus ions. Okay. Next, they conduct electricity in aqueous state. Who? Bases. pH value of bases more than 7. If it is 7, it is neutral. If it is more than 7, these are bases. The pH value is less than 7. Those compounds are acids. For examples of bases, NaOH, sodium hydroxide. And we can also give examples for bases. KOH is a base, NH3, ammonia is a base, where NaOH, sodium hydroxide is a strong base. Okay, and NH3, ammonia is a weak base. Later we will be learning about this strong bases and weak bases. So these are the general properties of bases. So before moving to classification of bases, let us check out with this difference between alkali and bases. So as we learned already, what are bases? Compound which reacts with an acid to give only salt and water. And all bases contain OH minus ion. And how do we get this NH4 plus ions? When NH3 reacts with H plus ions, it gives NH4 plus. Okay. So, a base is a substance which can accept a proton. That H plus is accepted by the base. Base accepts H plus ions. Okay. This point is important. You have to remember. And so, how this NH4 forms NH4 plus when NH3 reacts with H. And also you can give in the other forms also. I'll just show you now. When NH3 reacts with H2O, water, it can also react and gives NH4 plus OH minus. Okay. When ammonia is dissolved in water, NH3, which is dissolved in water, here water acts as an acid and ammonia acts as a base. Then the molecule of water donates one proton to the nitrogen atom containing a lone pair of electrons of the ammonia molecule, resulting in the formation of NH4 plus ion. Okay, and so here you can observe, here water is an acid, ammonia is a base, and here you get ammonium ion and OH minus is hydroxyl ion. Okay, sometimes the equation can be given just to identify or to fill in form of just choose the right answer like that. So as we look into this difference between alkali and bases, for example, here alkali we can give an example of NH3NaOH. Bases, we know NH3 is a base, NaOH is a base, sodium hydroxide, and copper hydroxide, CuOH2, all these are bases. So here, what are alkalis? An alkali is a base which dissolves in water and gives hydroxyl ion. The result end product must be OH minus. Okay, it must give along with the other salt, it must give OH minus ions, hydroxyl ions. Where NH3, it also dissolves in water and gives OH minus ions along with NH4. And NaOH, sodium hydroxide, also dissolves in water in aqueous solution and gives OH minus. But copper hydroxide will not dissolve. It is insoluble in water. Okay, so it is a base, but it is not alkali. Okay, so copper hydroxide is not alkali because it does not dissolve in water and gives OH minus ion. So this is the main difference between alkali and the bases. So sometime if it is in the descriptive type, they may ask the difference, that's it, and ask you to identify in the exams. Next, we shall now move to classification of bases. Okay, so how do they classify? Well, let us see one by one. Here, on the basis of acidity of the bases. Okay, so how the bases are classified into three types here: monoacidic bases, diacidic bases, and triacidic bases. So mono means one. So here acidity is 1, diacidic means acidity is 2, tri means 3. So let me explain that now. What are monoacidic bases? Bases which dissociate in aqueous solution to produce one hydroxyl ion. Means in case of mono, if they dissociate in aqueous solution and if they produce only one OH minus hydroxyl ion per molecule of the bases are called as monoacidic bases. Okay. In case of diacidic, same. Bases which dissociate in aqueous solution to produce 2 hydroxyl ion, 2 OH minus per molecule of the base is called as diacidic. Triacidic means which gives 3. So these are the differences. So here there are few examples I have taken. NaOH, which dissociate into Na plus OH minus, which gives only one hydroxyl ion. Example of monoacidic base. Okay, they may give a few examples and ask you to identify. You can just check out with this dissociation and explain or choose the right answer. Next, CaOH2 dissociate as Ca2 plus and 2 OH minus. Okay, so this is an example of diacidic base. Next, so this is water insoluble. CaOH2 is water insoluble. Next, in case of triacidic, AlOH2 in aqueous solution gives Al3 plus and 3 OH minus. So in case of this mono 1, di 2, tri 3, that's it. So here aluminum hydroxide you can give an example. Next, on the basis of the strength, bases are divided as strong bases and weak bases, like that of acids only, which already we have learnt. So what are strong bases? The bases which dissociate almost completely in the aqueous solution and producing high concentration of OH minus ions are called as strong bases. In case of weak bases, bases which dissociate in small extent, very little extent, thereby producing a small concentration of OH minus ion are known as weak bases. So you can express this. Examples for strong bases are NaOH is a strong base, as I have already discussed. It is as Na plus and OH minus, it dissociates as, and We can also give KOH is a strong base, BaOH2, okay. And for a small extent concentration, you can give an example of MgOH2, okay, magnesium hydroxide, and also NH4OH also you can give an example for. Next, on the basis of the concentration, bases are divided as or classified as two types: concentrated bases and dilute bases. Okay, so how this is divided? A base which is having relatively high percentage of base in its aqueous solution, like in case of acid we saw, based on the concentration of acid in the aqueous solution, that is concentrated acid. Here in case of bases, a base having relatively high percentage of base in the aqueous solution is called as concentrated base. Dilute base which is having low. So you will be taking two bases and comparing its concentration. Okay, hence you can say which is concentrated and which is low. So the difference between strength and the concentration already I have explained. What is that? So the strength of the base is the measure of OH minus ions which is present, okay, in the aqueous solution, whereas in case of concentration, that is the amount of base in its solution, how much amount of base is present in the solution. Next, moving to the next point, bases are proton acceptors. Okay, when base NH3 combines with hydrochloric acid HCl, it gives us NH4 plus and Cl minus. So this is one simple example to show that they are proton acceptors. Next we shall move to action of bases with acids. Very important point. So this kind of questions will be asked for TET multiple choice questions. The end product they can ask they can give this example and ask you which is a salt formed, or what is this along with which is assisting the salt. It could be, or in HSTR exams also they can give this equation, left hand side and right hand side could be asked. Okay, so very important. Action of bases with acids. We know as bases combines with acids form respective salt plus water. So what is the main product here? Water. Salt plus water. That is the thing we have to remember. For example, NaOH is a base which reacts with acid HCl hydrochloric acid, gives NaCl and H2O, water. So there could be question. When bases reacts with acids, it forms the respective salt and dash. So they will give different examples and you have to choose the answer as water. Next, quickly let us check out with action of bases with other compounds. So here action of bases with carbon dioxide or air. Let us take an example. Generally, alkalis absorb carbon dioxide to form the corresponding metal carbonate and water. Okay, so when air is passed through the alkali for a long time, the alkali absorb carbon dioxide from the air and to form corresponding metal carbonate. And alkali should not be left exposed to the air. That's why they keep the alkalis in a tight air container. Okay, they will not be exposed to the air for a long time. Okay, there could be questions. For GPSTR descriptive type, there could be questions. So here there is an example, NaOH, sodium hydroxide plus carbon dioxide, and it gives Na2CO3 plus water. Moving to the next one. Action with ammonium salt. The action of, whenever I say this heading, it is understood that action of bases. Okay. How they react with ammonium salt, NaOH, again taken the same example, plus NH4Cl, which gives us NaCl, sodium chloride, plus water plus NH3. Okay, means on warming with ammonium salt, the alkalis liberate ammonia gas, which is like pungent smell gas. Okay, ammonia gas is released along with water and sodium chloride. Next, moving to action of bases with heat. Generally, when hydroxides of metals between copper and calcium, or calcium and copper you can take, which comes first, right? Calcium comes first. calcium and copper. Between this comes titanium, manganese, iron, all this. Okay, nickel, cobalt. So between these two, so this hydroxides of metals, they in the electrochemical series decomposes on heating to form corresponding metal oxides and steam, nothing but water. So okay, here CuOH to copper hydroxide on heating gives CuO plus water. Next, action with metals and metal oxides. So here alkalis reacts with metals and metal oxides to form salts. It could be, main point to be noted here is they form salt. For example, zinc. When zinc reacts with NaOH alkali and it gives Na2ZnO2, that is sodium zincate. Sodium zincate plus H2. And again ZnO, if you consider that reacts with NaOH, gives Na2ZnO2 plus H2O. Okay, so these are the simple examples. They may not give this to explain in detail and all. They may ask you, it forms sodium zincate, or along with that, what is the end product, they may ask. As we revise with the question papers, we will understand what are the important points they will ask. So I will be stressing as I explain also. Okay. Next we shall move to neutralization. What is neutralization? Reaction of an acid with a base to form salt and water is called as neutralization. Okay. So main here is acids reacts with base AB. A plus B, acid reacts with base to form salt and water. This is called neutralization. For example, you can take simple HCl, hydrochloric acid, reacts with NaOH, sodium hydroxide. It gives NaCl plus H2O, which gives H2O, that is water. NaCl, sodium chloride, is a salt. Okay, very common basic example. And also I have listed of few other examples. HNO3 plus KOH is a base. Here this is an acid and gives corresponding salt and water. Here also for magnesium and sodium hydroxide, just now I explained this. Okay, so this is called as neutralization process. Next we shall check out with this question. What happens when carbon dioxide gases pass through lime water? Okay, so lime water is in aqueous solution, calcium hydroxide, CaOH2. This is nothing but lime water, right, in the aqueous solution. When this combines with carbon dioxide, CO2, what is the end product? First it forms calcium carbonate, CaCO3 plus water. Okay, so it's a clear colorless liquid. When carbon dioxide is passed through the lime water, it turns milky. First this will be colorless, lime water. Then when carbon dioxide is passed through it, it turns light milky. Then this is due to the formation of insoluble calcium carbonate. The calcium carbonate which is formed here is insoluble plus water. So this is the equation which is representing. On further passing this carbon dioxide, the lime water again turns colorless. Okay, here already you got which was colorless before, then turns light milk color. Then again passing the carbon dioxide, this lime water, already you have CaCO3 plus H2O plus carbon dioxide you are passing. Then it changes colorless soluble calcium bicarbonate, CaHCO3 2. Calcium bicarbonate, or you can also call as calcium hydrogen carbonate, which is lime water, which is a colorless product. Okay, an important equation to be remembered. Next we shall move to measurement of acidity and alkalinity, that is nothing but base nature, basicity we call. So how do we measure? In general, it is measured using three things, that is pH value, pH papers, pH universal indicator and pH meter we say. But there is a scale, pH scale. It means that is of potential of hydrogen, amount of hydrogen which is present in the given solution. So that is what is pH scale. pH stands for potential of hydrogen. Normally pH scale will be from 0 to 14 numbers. Okay, this is basics you might have already learned. 0 to 14. Where for the given solution, if the pH value is measured as 7, that is neutral. So you can identify whether it is an acid or whether it is a base. For example, you will be given one solution. You have to identify whether this is a base or acid or base. So if on checking out this values, if you get the answer which is below 7, between 0 to 7 if you get, then the given substance is acid. If it is more than 7, it is a base. So let us check out with few important points related to this. Generally, acids have pH which is less than 7. Alkalis or bases have pH which is greater than 7. And you can see 0. If they have 0 value in the pH scale, they are very strong acid. And if it is 14 value, strongly basic in nature. Then the more acidic a solution is, lower the pH, right? For 0, it is the more acidic. So lower is the pH value. The more alkaline is the solution, then higher is the pH value. Here 14 is the highest value, but which is a strong base. It's a strong base in case of alkaline, more the alkaline, and pH value is more. Next, neutral substances such as pure water have pH which is equal to 7. And how do we define this pH value? So pH is defined as the negative logarithm to the base 10 of hydrogen ion concentration. It is expressed like this: pH value which is equal to negative logarithm to the base 10 of H plus ions. So how do we write H plus ion? As H plus is equal to 10 to the power of minus pH. Like this we write. So these all sometime might be asked in the multiple choice questions. So how do we determine the pH value? The pH of the solution can be measured in several ways. So here there are 3 methods which is indicated. Measured using a universal indicator, then pH paper and pH meter. So what is a universal indicator? Universal indicator are mixtures of dyes. Okay, such an indicator gives a range of colors depending upon the strength of the acids or alkali added which is. So universal indicator that produce different colors for different acids. Indeed, solutions of same acid if you take also, they will give different color for different concentration. You are taking a same acid. Let us take hydrochloric acid only you are giving. This is a little weak and this is concentrated hydrochloric acid. So for the both different colors it will show when you test it. Then you can also use pH paper to check this value and also pH meter. The most accurate method involved in this is pH meter, which is used in the electrodes to measure the pH electrically. Next we shall check out with indicators. What are indicators? Indicators are substances that change their color or odor when added to an acid or alkaline solution. They are used in the chemical test generally. Examples: litmus paper. Okay, so in case of an acidic solution, if the solution is acid, if you take the blue litmus paper, it turns to red, which already we have learned. Okay, and turmeric is the natural indicator, is an example of natural indicator. So natural indicator that becomes red in the presence of acid but blue in the presence of bases. Natural indicator also. For example, you are eating and you have spilled some curry on your shirt, for example white shirt let us take. Okay, so that and you want to wash it and you are washing with soap, where soap is a base. So this nature of the color of the turmeric changes from yellow to reddish brown in the base medium. Okay, dark colors. Instead of blue, that reddish brown in the base medium it changes. And again you wash this shirt with water, plain water, the stain turns yellow again. Okay, so these are the example of natural indicators. Something special about this next one, indicators, they are olfactory indicators. What are olfactory indicators? Those substances whose odor changes in acidic or basic medium are called as olfactory indicator. So either in the acidic medium it will be different and in the base medium it will be different. Smell changes, not the color, odor. Okay, examples are onion, clove oil, vanilla extracts. All these are examples of olfactory indicators. So, how these olfactory indicators are used to detect whether the given solution is an acid or base. For example, you are given a solution, you want to check it, and you can take an onion strip, okay, or clove oil, anything. For example, onion strip. If you dip it in this solution and smell it again, if the smell of the onion remains the same, then the given solution is acid. Smell will not be changed. Okay, suppose when you dip this given onion strip into this given solution and smell it, if the it loses a smell, onion smell, you did not get it, then the given solution is a base. Okay, so in base, olfactory indicators loses its smell. This is how we identify the given solution is a base or acid, by using olfactory indicators. Okay, same with the clove oil, vanilla extract also. So next, moving to important properties of the indicators of acids and bases. So very important, these points could be asked in the exams. Let us first check out with indicator and the color change. For acids, in case of indicator, if you take blue litmus solution, acids turns blue litmus to red color. So if you get red color, turn the change, the final result, so you can identify, yes, this is danger, that there is acid present in that solution. Okay, if it is an phenolphthalein solution, that remains colorless. Phenolphthalein, to indicate that in the solution, if it is mixed, then if it is remain colorless, it indicates that that is an acid. For methyl orange, from orange to pink it is changes in case of acids. For universal indicator, it turns red. In case of blue litmus and this universal indicator, the color turns red. Then you can say that acid is present. In case of bases, how do we identify? In case of red litmus paper, when you dip it in the base solution, it turns blue. Okay, result is blue. In case of phenolphthalein, that color changes to pink. If the given solution, you are given phenolphthalein and you are added phenolphthalein to the solution, you have to identify whether this is an acid or base. If the color remains same, colorless, then the present solution is acid. If the color changes to pink color, okay, girls favorite color, pink color, then you can say that this is the base solution. In case of methyl orange, color changes to yellow color. Okay, previous for acid, methyl orange changes to pink, don't get confused. Methyl orange, in case of base, it changes to yellow color. In case of universal indicator, it turns blue for weak bases, it turns violet for strong bases. So either of this violet and blue common. Next, in case of turmeric paper, it turns from yellow to brown. Then you can say that presence of base. So later we will discuss about few multiple choice questions based on this acid, bases and salts together. Okay, then you will able to identify, and type of question also you will understand. Now I am just explaining the concepts, why it means. It will be easy for TET exams. If you want to appear also, it will be easy for GPSTR, HSTR. If you know the concepts, then it will be easy for you. Then for thorough practice, we shall take out with the question papers also later. Now we shall check out with few pH value of some common substances. Okay, dilute hydrochloric acid. Here I have listed out only few. You can just refer for later. You can refer more references. Generally the important ones I have listed here. Hydrochloric acid pH value is about 1.0. Soft drinks about between 2.4 to 4. Lemon juice 2.5. Orange juice 4.1. Black coffee 5. That's why you should not drink more coffee, okay, acidic in nature. Acid rain, it is about 5.6. For milk, it is 6.5. Rainwater 6.5 almost. For pure water, what is the pH value? It is 7. Okay. Then for human blood, it is alkaline in nature because it is basic in nature, 7.3, more than 7. Baking soda, base, so 8.5. Toothpaste, 9. Lime water, 11. Okay. So these are the bases. These all acids. So these are the general pH value. Sometimes they may ask you to identify, just identify the pH value of the lemon juice. If they give, it is an acid, so 2.5 you can just identify. So with this I have covered important points from bases and also in the previous video about acids. In the next video we shall continue about salts, importance of salts, important points. Okay, later all the question paper questions, the repeated questions from TET exams, GPSTR, HSTR exams, multiple choice questions also we will discuss. I will be giving a few questions. You can just practice questions also, type of questions I'll be giving later in the videos. And also I'll try to explain in Kannada. Let me not mix up in both the languages in particular video. I'll take separate video for Kannada and separate video in English also for the respective concepts putting together. Okay, subscribe my videos for more videos which will be useful for your HSTR exams also. Please comment in the comment section whether these videos are useful, so that it will be helpful to go with the more topics. Okay, thank you for watching.